Greens and machines. Greens and machines. Greens and machines .com. Greens and machines. Greens and machines. Greens and machines .com.
So this project was inspired by a few things. Namely,
why are Technics 1200 so expensive?
And...
No, really, why are Technics 1200 so expensive?
And then...
Whoa, Technics 1200's discontinued. Oh, they started making them again. But $1,000 each?
But also the fact that on my first pair of direct drive turntables, the platters were so unstable that the needle would be bouncing around even with mild pressure on the platters. So I figured I could at least do better in that regard. And the fact that I have a foundry and I wanted to make something cool, so why not a turntable?
This project is separated into 7 parts. Making the base pattern, casting the base, machining the base, making the platter, making the Tonearm Linkage, the Headshell Connector, and then final assembly. We'll begin with the base pattern. I started this project a few years ago. You might remember a video of me machining a 16-inch diameter piece of wood on my lathe. Well, this is what it was for. I also cut out the smaller corners on the lathe, but these were a lot easier. I chose this weird half-circular, half-rectangular shape for my turntable, not as a tribute to the Philips logo, but I thought this design would be easier to cast in one piece, and it would save material. I began assembling the pattern by cutting out a template plate on the CNC router. This would help align the pieces as I built it up. Once I had all the pieces screwed and glued together, I could remove it from the template. I then smoothed it out as best I could, and added fillet radii with glue mixed with sawdust, which didn't really work that good. Lastly, I painted it to give it a smooth finish for the sand mold. Alright, let's go cast it. I had to make this really massive flask because prior to this I'd never casted anything this big. There were a host of other upgrades I needed to do, which I've described in another video. I was told in Foundry Academy that I could mold something like this with a huge window pocket by ramming half of the sand from one side, scraping it down, and then ramming the rest of the sand. In theory this would work, but the turntable base was such a weird shape that ramming the opposite sand would just knock out a big chunk from the middle. After several failed attempts like this, I decided my only recourse was to build a sheet metal shield to fill in this gap. After that, the molding worked. I then fired up the foundry and successfully cast it. The next step was to clean up the casting and machine it so all the other parts could attach to it. I started by setting it up on the milling machine to face the bottom surface smooth. My design for the platter bearings changed part of the way through, which meant the original bearing boss wouldn't be big enough. As a result, I had to make a bigger bearing boss and attach it on separately. This was machined on the lathe. I milled and bored open a hole for it and attached it on with 3 screws. Next, I drilled and tapped a hole where the Tonearm linkage would attach. Now for the platter. I decided for this I would use a different molding technique called sweep casting. In this method, you can cast radially symmetric items without having to make a pattern for them. All you do is make a cross-section of the part and sweep it around a central axis to remove the sand layer by layer. I was told this method requires a lot of skill, and I found that out the hard way. The problem was I accidentally scraped a bunch of sand off of the parting line, causing the metal to leak out of the mold when I poured it. Amazingly, the casting still came out, but it was a lot thinner than I wanted it to be. And also the top boss for clamping on didn't even come out at all. In order to machine the underside, I had to make a separate boss and attach it on. I machined a small counterbore for registering this boss, but this made the section of the platter even thinner, resulting in a lot of chatter when I machined it. The next problem involved the spindle mounting mechanism. I was originally going to hold the spindle on with a taper, like the Technics does, but I figured since I'm using a belt drive, the radial force might pop this off. So I designed a bigger spindle to hold on with a set screw. The problem with the platter was I had no way of drilling this set screw hole because it would drill straight through the belt groove. My solution was to mill a slot and dowel in a threaded insert, which of course led to another problem of the section being too thin and cracking later on, but it did work to some degree. As for the V-belt groove, I didn't want to risk the chatter messing up the finish, so I filled in the bottom of the platter with Bondo to give it more rigidity. I then machined the groove and refinished the outside of the platter for a better finish. Unfortunately, I was too lazy to make a proper setup when machining the belt groove, so it didn't even come out true, causing the turntable to not even rotate at a constant speed, but oh well. Moving right along, let's look at the components for the Tonearm linkage. I didn't want to recreate this confusing looking gimbal mechanism that the Technics has, so I created my own design, which was a lot simpler. There was a Tonearm swivel, a pivot, a bushing, a shaft, a set screw collar, a counterweight stub, and the counterweight, and a lock ring, which I ended up not needing because it would have made it too tall, and then the Tonearm itself. I go into more detail on each of the pieces on the blog post. The most difficult part of this build was definitely the Headshell Connector. I decided to recreate this so my turntable would be compatible with standard headshells, so I wouldn't have to disconnect the cartridge wires every time if I wanted to change them out. This connector features 4 spring-loaded brass contact pins, a slotted body for the headshell pin to key in, a threaded lock ring to secure this pin, an insulator to house the contact pins, and it all fits into such a small component, leading to most of the challenge. I machined the body out of a piece of aluminum. Similarly, I machined the lock ring. One mistake I made was my Tonearm was too big, which prevented me from sliding on the lock ring from the back. As a result, I had to fit it on the front with a snap ring instead of a shoulder like it should have been, which caused the problem of the snap ring being able to rotate, blocking the pin slot. I machined the contact pins out of some brass screws I had lying around, which had to be turned down to 50 thousandths in diameter. The insulator I failed making a few times, firstly because the piece of plastic I found was actually fiberglass. The second one failed because it was wood, and the grain structure was interfering with me trying to drill holes so small. It finally worked when I had a piece of nylon to work with, that I could drill decent holes into. I had to special order the pin springs from one of those websites where you needed a $35 minimum order, making this the most expensive component of the turntable as well. Alright, let's put this thing together. One of the features that I missed about my old Stanton turntables were the removable RCA and power connectors. I decided I'd replicate this on my turntable. To do this, I created a little outlet box from some aluminum sheet. I drilled and sawed open a hole in the back of the turntable casting and bolted this on. As far as the electrical is concerned, a 6-volt power input is connected to a switch and a potentiometer for varying the motor speed. Though given my knowledge of electronics, this wasn't even the correctly rated potentiometer. And on top of that, I couldn't even find a 6-volt adapter strong enough to turn the motor at full speed. I tried wiring 3 6-volt wall adapters in parallel, but it still couldn't get enough amperage. I resorted to using a variable power supply for the testing. Next thing was to cut the Tonearm to size. The idea here is to make sure the needle is tangent to the record grooves. As for the Tonearm wiring, the 4 pinouts from the headshell connect directly to the RCA outputs. I used the same pin connectors that came with my needle cartridges, since the pins were about the same size. I soldered these onto the Tonearm wires and fed them through the hole in the Tonearm linkage. These were then soldered onto the outputs. I found that the original pulley that came with the motor was too small to spin the platter at full speed. That, and it wasn't even tall enough to fit through the casting, so I had to mount the motor upside down. To fix both these problems, I machined a larger pulley with an offset that would allow me to do this. A few more problems that I had included the belt rubbing on the base casting from the high points that came out when I attached on that sheet metal shield, so I just milled these down. Also, the Tonearm boss was too tall, so I milled that down as well. My intent to make the Tonearm linkage as rugged and heavy as possible backfired on me when I realized all that weight was making so much friction that the needle wouldn't even advance to the next groove, it would just keep skipping. To fix this, I machined a small brass washer to go between the bushing and the swivel. And that's about it. So let's try it out.
Alright, let's hear how Earth, Wind, and Fire sounds.
Oh yeah, the motor's really loud too. Let's listen to some of my own music instead. I'm using this program called Serato that lets you play any music from the computer as if it were a vinyl record. Probably one of the greatest inventions of all time.
Sailing on a bicycle, oh what a joy, my life is full of so much adventure, such a pleasure in the summertime sunshine, desert treasure, who even knows what will we find, just see the arrow on the sign and head down the street to find the place, such a great way to spend a Saturday.
So to better illustrate how accurate the speed is, let's play a test tone. I guess if my scratch samples are short enough, no one will notice the speed is off. So I think I kind of answered my question. Technics 1200s, because you're probably not going to build your own turntable.